Hello everyone, so this is problem number 14 of chapter SHM from Verma. In this question, it is given that there is a mass of a block of mass m is kept on a bigger block of mass capital M, which is attached to a vertical spring like this, which having a spring constant of k. Now, uh, this is saying that find the resultant force on the smaller block when it is displaced through a distance x above the equilibrium position. Suppose this is the equilibrium position or this is the mean position. If it has displaced, okay, let this be the mean position, and it has displaced a distance of x from the mean position in up vertical up direction. So what is the resultant force of the smaller block? So if this smaller block is moving along with this bigger block, so this both will perform a simple harmonic motion. So at this location, suppose the acceleration of this both block is a here. So a is equal to nothing but omega square into x. So this is the value. Now if let us draw the FBD of m. So it has many forces, that is mg, that is normal reaction, and whatever. Let the net force on this m block is F net, which is creating an acceleration of a for this block. So we can write the resultant force is acting is equal to mass into acceleration. So it is m omega square into x. Now omega is equal to, we know that is k equivalent upon m equivalent. So here the total spring constant is k and total mass is m plus capital M. So this is going to be m kx upon m plus m. So this is the force, that net force or resultant force which is acting on the smaller block. Now part B. This is the block. There is a force mg. There is a normal reaction which is offered by the bigger block, and this particle is moving with an acceleration a. So what is the normal reaction at that instant? So we can write that mg minus n is equal to mass into acceleration. So normal will be mg minus mass into acceleration. So that is mg minus mass into acceleration is nothing but net force or resultant force, that is mkx upon m plus m. Now C part. For maximum acceleration, what can be the maximum acceleration or what can be the maximum amplitude that it can have so that these two blocks may oscillate together? So let us consider the extreme position when this block is just leaving the bigger block. That means let the acceleration of this block be, both block be a. So that a be minus omega square into x, or we can say that minus omega square into a. Here minus we are not considering because we have already taken the sign or direction. The force is mg, other force is normal. So what is there in all mechanics? That first thing is draw the free body diagram. That is what is the forces acting, get the acceleration, and that's all. So here we are doing the same thing. I'm drawing the free body diagram. Acceleration is this much. So we'll write that mg minus n is equal to mass into acceleration. Now for the maximum acceleration, mg, it cannot change. There the n can change. So if we need a is equal to a max, so we need to have n as 0. So a max is equal to g. So if a max is equal to z, so a max is omega square into a, that is equal to g. So a is equal to g upon omega square. Now g upon what is the omega square? Omega is equal to k by m plus m. So k by m plus m. So this is the maximum displacement or maximum amplitude which this both block can have when it will have a zero acceleration. Sorry, it will not lose the contact. If we have an acceleration or if we have an amplitude more than this, so definitely the smaller block will fly away.